Hello, hello, hello. Welcome back. Chapter 5, the nth roots and rational exponents. So chapter 5, we'll be covering rational exponents and radical functions. Radical, not Abby Hoffman. It's just the radical functions. Okay. So there's 1, 2, 3, 4, 5, 6 sections in chapter 5. The first one we'll be covering is nth roots and radical expressions. So first thing you want to do in your notebooks is to put this in right here. This is on page 238. Page 238. Stops going back and forth. Put this in your notebooks. 5, 4, 3, 2, 1. Okay, so I'll go over this. This is if n is an integer, okay, it has to be positive, and a be a real number. You have, when n is an even integer, you have this stuff. When n is an odd integer, you have that stuff. So let me go over that stuff. What this means? We have this. So this is a radical expression. This is an exponential expression. That symbol right there is a radical. And that is a radical expression. This up here is it's an exponent. So this is an exponential expression. So radical form, exponential form. And a radical expression, an exponential expression. Okay. N is the index. You can also write it like this. You can also write it this way. Blah, 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 blah. Okay. B is going to be the nth root of A. Okay. You're going to use a calculator for the stuff. Remember, n has to be an integer greater than 1. N has to be a positive integer. So when you have a radical like this, when these are positive integers, come on, there we go. Okay, when this is going to be an even integer, when this right here, when n is going to be an even integer, in this case, if you have a negative inside, when a is negative, when a is less than 0, in this case, it could be a 2, it could be a 4, a 6, 8, 10, 12, 14, 16, 18, blah, blah. As long as that's an even integer, there will be no real nth roots. You're going to get an imaginary number, but you're not going to get any real roots. Okay? If a is 0, if that's a 0, and n is positive, it doesn't matter. That's always going to be 0, whether that's positive or negative. That's always 0. And when a is greater than 0, or when a is positive, in this case, you can get 2 real nth roots. So be careful of this, because this is where people make mistakes. Here's an equation. This right here, there is an equal sign right there. And so when you rewrite this, you have an equal sign and a variable. So to solve for that variable, you always do the opposite. You have to get this 2 to the other side. The opposite of squaring is square root. And when you do that, we'll whoosh, x equals square root of 9 is 3, but don't forget to do that plus or minus. So when you have an equal sign and a variable, and when you do the square root, you'll get 2 roots, 2 real roots. Now, here, is there an equal sign there? No. Is there a variable? No. You have to have an equal sign and a variable. Okay, there is no equal sign and variable, so in this case, you just get 3. In that case, it's just one answer, because there's no equal sign there. Okay, that is equivalent to 3. In this case, you're starting off with an equation and a variable. So when you take the square root of both sides, this is going to be plus or minus 3. You get 2 answers in this case when you have an equal sign and a variable. Over here, you do not have an equal sign and a variable. Okay? So what happens if this same thing, if we just rewrite this whole thing, in this case, this was for when n is an even number, when n is an even integer right there. What if you do the same thing when n is an odd integer? When n is an odd integer. Do you get any different answers? Yeah. Look at this. The third root of negative 8. So basically you're saying, is there something, when you multiply it 3 times, it's a negative 2 times negative 2 times negative 2 is equal to negative 8. So that right there, you're looking for, instead of an identical pair, we're now looking for an identical triple. That right there is identical triple, and the answer is going to be -2. You only get one real answer, one real nth root. In this case, doesn't matter if this is odd or even integer, that will always be 0. So you get one answer. In this case, the fifth root of 32. So can you write 32 when you have 5 of the same things? Yeah, 1, 2, 3, 4, 5. So here you're looking for an identical quintuplet. 5 of a kind. Yes, 1, 2, 3, 4, 5. So cross it out and you just get an answer of +2. Okay, so it doesn't matter if A is negative, you get one answer. If A is equal to 0, you still get one answer. If A is positive, you still get one answer. So be aware of that. You can get 2 answers only if this index is a even integer. Okay? And we'll go over that some more, some practice. And here's some rational expressions, this stuff. Rational exponents. Let a to the power of 1 over n be an nth root of a, and let m, the letter m, be a positive integer. Then you're going to get this stuff. So a to the power of m divided by n, you can write it this way. You can also write it this way. It's just different ways of writing it. You get used to writing in both ways, because sometimes it's easier to solve something this way, sometimes it's easier to solve it this way, sometimes it's easier to solve it that way. You need to be able to interchange that. If this is raised to a negative power, that's a negative right there, then you just take this, that right there, and you take the reciprocal. And so you take the reciprocal and change the exponent from a negative to a positive exponent. And then you can do the same thing. And just this goes, nike, you still have 1 in the numerator. Okay? And this is as long as a, this denominator cannot be 0. A cannot be 0. So this stuff is going to be really useful. I told you to copy this down before. It's very, very useful. Okay, let's go to the book. The book says, we got here. Find the indicated real nth roots. Example 1. Oh, that's this stuff right here. That's this stuff right here. So we have doink. So we're going to use this. We're going to start off with, in this case, let's do number 6. Question 6. Can read that? There we go. Question 6 says, n is 5, n equals 5, a equals -1. Okay, so we're going to use this expression. A is -1, n is 5. So -1 to the fifth root. So use a calculator. If you use a calculator on this stuff, wait a minute, do I need to use a calculator? Because I know the answer is either going to be 1, -1, or there's no real answer. So, the fifth root. 1, 2, 3, 4, 5, 5. Oh, look at that. Good thing this stuff is going to be very useful in the last chapter, in chapter 5, chapter 6. When you take this right here, number 6, the fifth root, -1 is -1, you're going to get -1. Okay, that is an odd number. It's an odd number, odd integer. Okay, you're only getting one answer. In this case, it's -1. Ooh. Pick that back up. This is your answer. You can use a calculator if you want. Calculator. 1, -1. There we go. And that is the same thing as -1 raised to the power of 1/5. It's the same thing as raised to the power of 1/5. Okay, raised to the power 1 divided by 5 equals, you get -1. So you can do that on a calculator if you want. Number 8. Number 8. N equals 4. A equals 256. So we're going to take this expression. A is 256, and the index is 4. That's the same thing as 256 raised to the power of 1 over 4. Okay? That's this stuff right here. Okay? It's also using this. Okay, so 256 to 4. Oh, geez, I don't even need a calculator because 256, the fourth index, 234 right there. Do I see a 256 in that column? Yeah, right there. So the fourth root of 256 is going to be 4. Oh, the answer is 4. Okay, okay, that's an even number, so even integer. When it's an even integer, you're either going to get no answers, one answer, or 2. Okay? There's no equal sign, it's just an expression. So here you won't get 2 answers, you're just either going to get an answer, one answer, or none. And if that's an even number, if this inside here was a negative, you would not get any real answer. It would be a imaginary. In this case, you're going to get 4. Okay. Question. Here, so this is what I don't like about this book. This book says you start with this, and you're going to get plus or minus 4, the fourth root. And I don't like about this. 256 raised to the power of 1 divided by 4 equals 4. If there was an equal sign in there, you would get 2 answers. But when you just start with this, right here, there is no equal sign or variable. So you only get 1 answer. It's 4, not plus or minus 4. Number 10. Número 10. N is 6. A is negative 729. So you have this. Take this. A is negative 729. N is 6. This 6 index is 6. The 6th root of negative 729. Find the indicated real nth roots. Okay, that's an even integer. And inside this radical you have a negative. You're not going to get any answer. There's no real roots here. No real roots. It's negative. You're going to get an imaginary answer, but it's not going to be the real answer. Okay? This stuff comes in handy a lot. Next, number 11. So number 11, evaluate the expression without using a calculator. So 64 to the 1/6 power. 1/6. Do I see a 60? I'm looking for a 64. 1/6. Look at that, 64 right there. The answer is 2. So that right there. By the way, I don't like when they do this kind of at a diagonal. I'd rather, instead of writing at a diagonal, do it this way where it's horizontal line, 1/6. 1 is the numerator, 6 is the denominator. Visually, it's easier to understand. That right there is going to be, that right there is the same thing as 2. Good thing you made one of these. It's so much easier. Question 15. Take this, solve this without a calculator. Oh, 243 to the 1/5. Oh, the 5th power. There's 5. Is there 243 in that column? Yes, there is. I don't need a calculator because the answer is going to be 3. Oh, wait a minute. That's an odd number and there's a negative. Can we do this? Yeah, if that's an odd number, your answer is going to be a negative. If not 3, it's just negative 3. Okay. If this was an even number, you would get no real root. Okay. If that was a 2 or a 4 or 6 or 8 or 10 or 12 or 14 or 16, you would get no real root. You'd get some imaginary answers. Okay. Next, let's go to question 22. Match the equivalent expressions. Explain your reasoning. Number 22. So we have this. I'm going to take 5. This right here, this stuff. Get a different piece of paper. 4. And let's go Let's go 7, and let's go 9. Just make it look different. This right here is going to be 4 raised to the power. This index right here is going to be on the bottom. This exponent is going to be on the top. So this would be the same as 4 raised to the power of 9 over 7. If you had something like this, 12, and the root here is 5, and this is raised to the 3rd power. This would be 12 raised to the power. That 5 would be, this index 5 would be in the denominator up here, 5, and that this 3 is in the exponent would be in the numerator, 3. So that would be equivalent to 12 to the power of 3/5. Okay. So when you get to this stuff here, you have to take these and match it up with A, B, C, D. That's all you're doing here. Stuff just like this. Okay. We get to question 25. Question 25. No, let's do 27. So 27. 27 is 25 to the power of 1/3, or 25 to the power of negative 1/3. And it says, use a calculator. There you go, use a calculator. Ta-doink, ta-doink. Can you see that? 25 raised to the power of parenthesis negative 1 divided by 3. Can we see that right there? Negative 1/3 equals. We're going to get 0.341995. We get 0.31995. I'm going to round that off to 2 places past the decimal. So we're going to get this. Okay. So you get this answer right there. Next one. 20736 raised to the power of 4/5. Use a calculator. Oh. 20736 raised to the power of parenthesis 4 divided by 5 equals. So you can see that. Raised to the power of 4 divided by 5. Is that 2 in there? 2, yeah, the 2's got in there. Yeah, it's in there. Equals. Okay. You get 2840.40316. 2840.40316. Go 2 places past the decimal, so that is equivalent, and is approximately equivalent to 2840.40. Okay. Go round off 2 places past the decimal. In this case, question 33. Question. Exercise 33 and 34. Find the radius of the figure with the given volume. So I'm going to do something. I'm not going to do this exact question. I'm going to do something very similar to that. Okay. Instead of having a volume of 216, we're going to make it so the volume is 400. So we'll do this way. The formula you're going to use is this formula right here.